So this is homework problem 4.3, problem 223b. So again, we're going to be using the Laplace transform to solve this ordinary differential equation. So first step is going to be taking the Laplace transform. So using this general equation for the transform, we'll apply it to our ODE. So m is 1 here, so it's just going to be s squared x of s minus sx of 0 minus x dot of 0 plus c, which is 10 sx of s minus x of 0 plus k, which is 25 x of s equals f of s. So since this is a constant, it will be 75 over s. So then step 2 is solving for x of s from this equation. So we're just going to rearrange this into an easier form. So s squared plus 10s plus 25 x of s equals 75 over s plus s times 10 plus 4 plus 10 times 10. And that was from applying your initial conditions. So here this is 10, x dot of 0 is 4, and then this is also 10. Then simplifying this out even further, you're going to get 10s plus 75 over s plus 104. Right, so moving on to solve for x of s, you're going to use your general answer over here, 10s plus 75 over s plus 104, and then divide that by your characteristic equation, s squared plus 10s plus 25. And then simplifying that down, we want this s in the denominator, so 10s squared plus 75 plus 104s all over, and if you factor this out, you'll have s times s plus 5 squared. So moving down to put it with our constants, we have c1 over our first denominator term, s plus 5 squared. Since it's squared, you want to do c2 over s plus 5, which is to the first power, and then c3 over your third denominator term, s. So if you multiply this out to put it all together, we'll use c1s plus c2s s plus 5 plus c3 s plus 5 squared all over s times s plus 5 squared, because you want the same denominator here, so you can set your numerators equal. So moving on to keep solving for our constants, n of s equals your numerator 10s squared plus 75 plus 104s equals your numerator here c1s plus c2s s plus 5 plus c3 s plus 5 squared. And then we're going to put these in similar forms, so converting this, you're going to end up with c2 plus c3 s squared, because those are all your terms multiplied by s squared, plus c1 plus 10 c3 plus 5 c2 are your terms multiplied by s, and then 25 c3 is your constant term. So setting our terms equal to solve for our constants, we have 10, which is the coefficient here for s squared, equals c2 plus c3, which is our coefficient for s squared here. The next one, 75 is our constant. We look at our constant terms, so 75 equals 25 c3, and then the last term multiplied by s, you have 104 equals c1 plus 10 c3 plus 5 c2. So immediately looking at this equation, 75 divided by 25, you get c3 equals 3. Plugging that into this equation, you have 10 minus 3, so c2 equals 7. And then plugging c2 and c3 into this equation, you get c1 equals 39. So moving on to the third step, you're going to take the inverse Laplace transform of your x of s equation, which is given by your constants. So you're going to have x of t equals the inverse Laplace of x of s, which equals c1, so 39 over s plus 5 squared, plus c2 over s plus 5, plus c3, which is 3 over s. And then if you look at your Laplace transform table, for the first one, s plus 5 squared, you're going to want to use this equation. So that's going to give you, you have your constant of 39, so it'll be 39, and then it would be over, since it's squared, 2 minus 1 factorial, which is just 1, multiplied by t to the 2 minus 1, which is just t, and then e to the negative at. Since there's a 5 here, it's going to be e to the negative 5t. So then the second one, you're going to use this equation, the 1 over s plus a. So you have your constant 7, so it'll be plus 7, and then e to the minus r value here, minus 5t. Then your last one, since it's just 3 over a constant, 3 over s, you'll have 3u s of t. And that will be your Laplace transform of your ODE.